So, solubility refers to the maximum amount of solute that can be dissolved in a given amount of solvent at a specified temperature and pressure. There are three different types of solutions that can result depending on how much a particular solute is dissolved in the solvent. So, a saturated solution contains the maximum amount of dissolved solute for a given amount of solvent at a specified temperature and pressure. An unsaturated solution contains less dissolved solute for a given temperature and pressure than a saturated solution. And a supersaturated solution contains more dissolved solute than a saturated solution at the same temperature. And in order to form a saturated solution, you must dissolve the solution at a high temperature and cool it slowly. Under normal temperature and pressure, you should have a solute left in the solution that wouldn't dissolve, but by increasing the temperature, the solute will dissolve in the solution.
I have a question.
Yes.
So if you want to put more, like we did in there, if it was to cool off, would it undissolve? Yeah.
So if you cool it off slowly, it won't dissolve, or won't undissolve, but if you do it quickly, or add too much, it's unstable, it will fall out. That's actually what's happening on the crystals. Is over time, some of the sugar solution is coming out of solution, but it's growing on the crystals. The crystals act as a source for them to fall out of. So, all the information will help you read a solubility curve, with plots which plots different amount of solutes that are dissolved in 100 grams or 100 milliliters of water at a particular temperature. When ready, the curve of a particular solute, it's important to see at what temperature the solute creates a saturated solution. So if you put in exactly the right amount for the solubility, you get a saturated solution. So if you measure it and it's on the line, it's saturated.
If it's over, it's saturated?
Yes. So at 55 degrees Celsius, a saturated solution would contain 120 grams of solute of sodium nitrate. So we find sodium nitrate, we go to 55 degrees, and we see it's on the line right here at 120. That means that if we're right here, 55 degrees, 120 20 grams per 100 grams of sodium nitrate, it'd be saturated. This point is exactly on the solute's curve. If you were to mix 140 grams instead of 110, we would create a supersaturated solution if we get it all to dissolve. Note that just by putting 140 grams doesn't make it supersaturated. You have to get all the 140 grams to dissolve. Another example would be if you put less than 110 or 120. So let's say we put 110, which is too low. It's under the curve. So if it's under the curve, we can get unsaturated solutions. If it's above the curve, we get supersaturated. And if it's on the curve, it's saturated. Make sense? Now keep y'all's mask on. Lift your head up, Ryder. Ryder, lift your head up. Understanding how to read solubility curves allows for many different types of questions you could that could be asked by you. For example, find the temperature you could create a saturated solution for a particular solute. So this is an alternative formula. So let's say we have this question. How much salt can you add to 50 milliliters or grams of water at 20 degrees Celsius room temperature? So I showed y'all cross multiply technique. So first we need to figure out what the solubility of salt, which is NaCl, is at room temperature 20 degrees Celsius. Looking at the curve, we go 20 degrees Celsius. We see Na is about 37. So that means it's 37 grams NaCl per 100 grams water, or 100 milliliters water.
So you divide it in two.
And we're trying to figure out what it would be at 50 grams or 50 milliliters of water. You can cross multiply, or we can do another technique. This technique here is start with your known volume or a mass. So I'm trying to figure it out for 50 milliliters or 50 grams of water. And I multiply it by the solubility. The solubility is 37 grams per 100 milliliters of water. And I end up getting how many grams or milliliters or how many grams of salt I need to make a saturated solution, which would be 18.5 grams of NaCl. If you were to cross multiply, you get the same result. So this there, so that's 37 times 50. And then this over here, that's 100 times x. And then we divide by 100 on both sides. And I get 37 times 50 over 100. That's 18.5 grams is your x. So this is how you would find out how many grams of salt can be are needed to make a saturated solution for 50 grams or 50 milliliters of water. And by the way, if we're talking about water, grams and milliliters are the same thing. They're equal to each other. They're not the same thing. One's volume and one is mass. But 1 gram of water is equal to 1 milliliter of water. So, how much salt? Hello? No. Alright. They want you at the office to help. Haley. So how much salt can be put into 200 grams of water? Thomas, keep your eyes open.
54.
Close.
Oh, wait, no.
So again, we know that the ratio is 37 grams NaCl to 100 grams H2O, and we're trying to find the ratio of X to 200 grams of water. Yes, but you can cross multiply. So 37 times 200 is equal to this 100 times X. We're going to move this over and divide by 100. And we see that our X is going to be 74 grams. Another thing we can do is take our given amount, 200 grams of water, and we can multiply it by the solubility ratio. 37 grams NaCl per 100 grams H2O. And we get the same thing, 74 grams of NaCl is needed to saturate 200 grams of water. Yes. Go to the office. Mm-mm.
Just go to the office. It's going to be pretty easy. It's heated. Maybe in Florida? Maybe. Hopefully so. He's mad enough.
Alright, by the way, which of all these is the most soluble in water
H2O.
at room temperature?
H2O. The top left. No, this one.
Yes, this one.
Okay, how do you tell?
Because more grams of it can dissolve in water than anything else. This has 145 grams of this can dissolve in water at 20 degrees Celsius.
What's it? CE2 something.
Cesium sulfate.
What is that?
It's a gas.
Gas can dissolve in water?
Yes. Have you never heard of carbonated water, aka soda?
I thought it was gas.
CO2 dissolved in it. So, if I were to put 100 grams of potassium iodide into 50 grams, or no, 200 grams of water, how much more is needed to saturate the water? Meaning, how much more can I add, how much more can still be dissolved?
At room temp?
Yes, at room temp.
I think you just said it was what, 35? Well, 200, well, 170.
Alright, so the question is, what is the solubility for potassium iodide for 200 grams of water? What is it for the standard amount, 100 grams?
135?
145. So, 20 degrees, and y'all lift your head up. 20 degrees, potassium iodide for 100 grams of water is 145. So it's 145 grams Ki per 100 grams of water. But we want it for 200 grams.
Well, you should add 145 to it.
So, you're right. You can think of this as just adding another 145 grams per 100 grams of water. And another thing we could do is multiply this by 200 grams to figure out how much can be dissolved in 200. Or cross multiply. And we see that 290 grams of potassium iodide can be dissolved, and lift your head up, in 200 grams of water. Now, we're putting 100 grams, so how much more can still be dissolved? 190 grams of potassium iodine can still be dissolved. Remember that the units for solubility is always grams solute per grams, and the solvent is always going to be water for this class, or gram solute per milliliters water. And just don't write the word solute. This is the solute here. You put whatever chemical it is. Michael, what's your up? Alright, 50 grams of NaNO3 is dissolved in 10 degrees Celsius water and make that 50 milliliters. How much additional NaNO3 is dissolved? So this is supersaturated. So what's the solubility for 100 milliliters of water?
It is 20.
Stop tapping. So what's the solubility? 80. It's literally on the line right here. 80.
Oh my god.
So it's 80 grams of NaNO3 per 100 milliliters of water. And what would it be for 50 milliliters of water?
Divided by 2.
So yes, we just need to divide this by 2, so it would be 40 grams NaNO3. So how much additional NaNO3 is dissolved? We put 50 grams into it and forced it to be dissolved. So how much is over the solubility? Keep your mask on. 10 grams over it. So 10 grams over solubility or saturation. So make sure you check out how much water you're putting into it and convert. The curve only tells you for 100 milliliters. You need to convert it into how many milliliters is specified. And if it isn't mentioned, assume it's 100 milliliters of water. So if not specified, assume 100 milliliters of water. Everyone good? Homework.
Oh, okay. Can we go check on our fish? Looks like comments and
Yeah.
It's okay, John. Yeah, no. The only worst thing can happen. I'm working on the floor. I'm working on it. I don't want to get in Next job is.
What is this?